Hi, in this video we will see how to solve the permutations. So we are given an array of distinct integers, so there are no repetitions, and we need to return all the possible permutations. Let's see how we can solve that. So we'll take the same example. We are given 1, 2, 3, say 1, 2, 3, and we have three placeholders. So in the first place, I can use any one of those, either 1 or 2 or 3, because I haven't used any of them. So say I've used 1. For the second portion, I'll be only left with 2 and 3 because I've used 1 here. So let's say I use 2, and for the third portion, I'm only left with 3. Now that's it. This is one permutation. What we can do is, like, we can see if we can fill any other element in the third portion. As there are only 3 elements, I cannot fill any other element in the third portion. Okay, what I do is I go back and I'll try to see if I can fill any other thing in the second portion. I mean, there's 1 in the first portion. Can I fill anything in second portion? Yeah, we can try using 3 in second portion, because we have never used 3 in second portion. And now for the third portion, what we can fill? We have used 1 and 3, so we're only left with 2. So this is how we get the permutation. So in the programming approach, what can we do? So we can use recursion and try to explore all the possible permutation. So we start here. We have 3 possibilities: 1, 2, and 3. Right? I mean, 3 possibilities, like 3 elements in the array. So say 3 recursive, 3 calls. And now from here, how many recursive calls can I make for the second portion? It's 1, 2 or 1, 3, because 1 is already used, so only 2 calls are left. From here, for the third portion, 1 and 2 are used, so I can only use 3 for the third portion. And here, say 2. For the second portion, starting with 2 at first, what are the possibilities? I can try 2, 1, 2, 3. And for third place, I can try 2, 1, 3, and here 2, 3, 1. As you can see, the leaves of this recursion tree are the permutations that we need to return. So as 3 elements, we have 3 factorial number of permutations. So solve is the function that returns all the possible permutations. So as this is a recursive function, we have the base case. Base case is when do I stop? When the size of the array is total number of integers, then we have no more permutations left. So we copy the current permutation. So I'm creating a new array list called copy. I copy all the elements from array list and to this copy array list and add it to the result, which is list of lists. And again, so how do I create the recursion tree? So in the array, I have an has included. It's a boolean. It's a boolean array. It tells whether I have used up a particular element or not. So if I have used up, I cannot use it anymore because it's already been used at some previous place. If I haven't used, I can use it. So I make has included as true, and I've added to the array list, which will be part of the current permutation. Then I go in a step deeper, and again it's repeated. We'll try to include elements that haven't been included. And now again, while coming back, as a backtracking move, I'll remove the last element and make as included that as false. And after we've included all the possible permutations, we just return it.